All right, guys, here is our last new video of the chapter. We'll talk about our last new rule, and we'll do like the most difficult problem that I can think of. If you understand the most difficult problem, you should be able to do anything from this chapter. For our last rule, we're looking at a fraction inside of a parentheses with an exponent on the outside. Remember that the exponent on the outside tells us how many times that the inside happens. So a over b squared to the 4th means that a over b squared gets written 4 times. Now, when you're multiplying fractions together, you don't need a common base. And what you end up doing is you end up multiplying all the top numbers, and you multiply all the bottom numbers. So on the top, I have 1, 2, 3, 4 letter A's. So that will change to an a to the 4th. On the bottom, since the b's all have an exponent, we will be adding those exponents together. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. So my final answer for this problem would be a to the 4th over b to the 8th. Now, we could have gotten there quicker had we have known the rule. So looking at the original question and the answer, I hope that you can see that the rule is to take your exponent and distribute it to every base on the top and bottom of the fraction. So I took this 4 and I gave it to the letter A. It's over here, a to the 4th. And I took this 4 and I also gave it to the letter B. Now, since the letter B already had an exponent, those two got multiplied together. 2 times 4 is 8. And here is the generic rule. We'll start by just practicing this rule. And then for our last example, again, I'm going to try to give you something where you have to do all of the different rules. But let's try a simpler one first. So in this problem, it says z to the 2/3 over 5, and then the whole thing is being risen to the power of 3. So we'll start by taking that 3 and distributing it to the z and the 5. Don't forget that 3 was an exponent, so it still needs to be written as an exponent. It will be multiplied with the 2/3, which was already an exponent. And then when I give the 3 to the 5, it's going to be 5 to the power of 3, not 5 times 3. On the top, when I'm multiplying fractions, I can multiply straight across, or I can cross cancel. In this problem, those 3's will cancel. For the bottom of the fraction, I do need to figure out what 5 to the 3rd is. That's 5 times 5 times 5. And that's 125. This is my final answer for this question. So distribute to the top and the bottom. Make sure that if you're distributing it to a number, that the exponent stays an exponent and does not suddenly grow in size and become the same size as the number. All right, let's try that very last super tricky problem. In this problem, I'll go ahead and walk you through the steps in the order that you should take. Our first step has to be that rule that we just learned, where we distribute the -3 to everything inside the parentheses. Now, in this problem, I have 1, 2, 3 things on top and 1, 2, 3 things on bottom. So I will be distributing the -3 to a total of 6 bases. So notice that my 2 has an exponent of -3. For the letter X, I multiplied 6 times -3 and I got -18. My letter Y did not have an exponent, so now it does. It has an exponent of -3. On the bottom, my 4 has an exponent of -3. My X already had a -1, so we'll do -1 times -3, and that turns into a +3. And then for the y, I did 4 times -3, and I got -12. Now, there's a lot of negative exponents in this problem, and that is just not fun at all. So my suggestion for you for your next step is find anything that has a negative exponent and move it to the other side of the fraction. So let's get rid of all of those negative signs. Everything on the top of the fraction has a negative exponent. So all of those are going to move down to the bottom. So the 2 will move down to the bottom. This x to the 18th will move to the bottom, and then the y to the 3rd will also move to the bottom. On the bottom, only the 4 and the y had a negative exponent. So I'm going to move the 4 and the y up to the top. But the x to the 3rd will stay put because it already had a positive exponent. And this is what that looks like when you're done. Now all my negative signs are gone, which makes this problem look just so much nicer. Next, I'm going to simplify anything that I can on the top, and then completely separately anything I can on the bottom. On the top, the only thing that I can simplify is I can figure out what 4 to the 3rd is. 4 to the 3rd is 64. On the bottom, I can figure out what 2 to the 3rd is. 2 to the 3rd is 8. And on the bottom, I also have 2 letter x's. If you have the same variable on the same side of the fraction bar, you can combine them together using our rule for multiplication, which says add your exponents. So I will be adding the 18 and the 3 from the letter x's together. Next, I'm going to simplify my fraction. When you're simplifying the large numbers, they're actually regular size, but comparatively speaking, they look bigger. You're going to simplify them just like you were simplifying a fraction, like doing a regular division problem. So you want to think of it almost on its own. It's 64 over 8. So you just want to think of like, what is 64 divided by 8? And, you can divide both of these by whatever it is. I think they're both divisible by 8. So that'll give us 8 over 1. So you want to treat the larger numbers or the normal size numbers, you want to treat them as a regular fraction. You're not using your rules for exponents for the large numbers because they're not exponents. Okay, so the 64 and the 8 are going to cancel out and become just a number 8. On top because the 64 was here and that was on top. And then the x, this is my only letter x, so that's just, we're going to have an x to the 21 on the bottom of the fraction for our final answer. But I can combine together my y's. Now, when you're combining together variables from different sides, you always want to do top minus bottom, and you're always going to put that on top of the fraction. So I'm going to do 12 minus 3, and it's going to go on top of the fraction. 12 minus 3 is 9. When you're doing the subtraction, again, it always starts on top. If you subtract and your answer is positive, then it stays on top. If you subtract and you end up with a negative answer, then for your final answer, you would move it down to the bottom. Okay, but it always stays on top. So subtract top minus bottom and keep it on top. And then after you're done subtracting, then decide, does it need to move to the bottom? We can do a really quick check, make sure that we have a final answer here. So I only have one of each letter. That's perfect. That's good. My coefficients, my big numbers have been simplified as much as possible, right? I have a number 8. There's no exponents. There's not like a divided by 2 that I could simplify. So that's good. None of my exponents are negative or the number 0. So that's good. So I think we're done. This should be our final answer. So again, this is kind of the order of the steps. And then your job is to figure out, which of the different rules do I need to use for this problem? And some problems will require you to use all of the rules, right? Depending on the difficulty. This concludes all of our notes for this chapter.